A small company manufactures and sells two models of lamps, Funky and Snazzy, the profit per lamp being $15 and $10 respectively. They have two workers who make the lamps. Brian assembles the lamps and takes 20 minutes to assemble each Funky lamp and 30 minutes to assemble each Snazzy lamp. Bruce paints the lamps and takes 20 minutes to paint each Funky lamp and 10 minutes to paint each Snazzy lamp. Brian and Bruce can work at most 100 hours and 80 hours per month respectively. How many of each lamp should be made each month, assuming that every lamp that is made can be sold? In this type of question, the first thing you should ask is exactly what do I have to do? And there should be a sentence somewhere on the page that tells you what you need to find. Let me find that sentence. Here it is. How many of each lamp should be made each month? That sentence tells you what your variables need to be when you set this up using equations. So my variables need to be the number of each lamp. Let f be the number of Funky lamps made per month, and let S be the number of Snazzy lamps made per month. I need to be that specific, otherwise it won't make any sense. I can't just say let F be Funky lamps, because it's not. It's the number of Funky lamps made per month. So I need to be that specific, or it doesn't actually make sense what I've written down. Well, now what I'll do is I'll go through the rest of the question and I'll set up equations using the information that's there. And I'll need a new page to give myself enough space to do that. I usually find the easiest way to do this is to draw a table. We have two types of lamps, and they are Funky and Snazzy. And the number of each per month is F and S. That's the information I've got so far. Let me go back to my question and read each sentence and figure out what else I can put in my table. So, a small company manufactures and sells two models of lamps, Funky and Snazzy, the profit per lamp being $15 and $10 respectively. Let me put that in my table. Profit per lamp, $15 and $10. That's good. They have two workers who make the lamps. Brian assembles the lamps and takes 20 minutes to assemble each Funky lamp and 30 minutes to assemble each Snazzy lamp. I can put that information in. Also, time to assemble per lamp is 20 minutes and 30 minutes. Bruce paints the lamps and takes 20 minutes to paint each Funky lamp and 10 minutes to paint each Snazzy lamp. Let's put that information in. Time to paint per lamp, 20 minutes for the Funky and 10 minutes for the Snazzy. Brian and Bruce can work at most 100 hours and 80 hours per month respectively. Now that's not actually about our lamps individually, so I can't put it in my table, but I will put it on my page. So Brian was lamp assembly, so the amount of time we have for lamp assembly in total is 100 hours. So total assembly time per month has to be less than or equal to 100 hours. Okay, and what was it for the other guy? Bruce can work 80 hours per month, and Bruce was painting. So total painting time per month is less than or equal to 80 hours. Okay. Well, I've actually finished all the information in my question now. I'm back to the last sentence. And it was the last sentence that told me that I needed to let F be the number of funky lamps and S the number of snazzy lamps. So now I need to just look at the information I've written in my table. Alright, so over here I've talked about the total assembly time per month. So I should figure out what the total assembly time per month is in terms of F and S. So let's see, I've got F funky lamps and they take 20 minutes each. So the total time, total assembly time, is 20F and 30S, because I've got S snazzy lamps and they take 30 minutes each. And together these make up the total assembly time in minutes. And over here I've got total assembly time per month in hours, so I should convert that to minutes as well. Let me do that. And I'll write it as a new inequality down here. So I get 20F plus 30S is less than or equal to 100 hours, which is 100 times 60 minutes, so 6,000. And that deals with the total assembly time per month. Let's move on to the next one. This time I want the total painting time per month, and the time to paint per lamp I have here. So if I draw a new row in my table for the total painting time, total painting time, I have F funky lamps and each of them takes 20 minutes to paint, so that's 20F. And I have S snazzy lamps and each of them takes 10 minutes to paint, so that's 10S. So, putting all this together, 20F plus 10S should be equal to the total painting time per month. Well, less than or equal to 20F plus 10S is less than or equal to 80 hours, which is 80 times 60 minutes, which is 4,000 minutes. So that's all the information we have there. What I might do is just rearrange what's over here on the side of the page into a more logical order, so that the equations that relate to the same thing are next to each other. That's better. Now I have total assembly time per month and the equation that goes with it, and total painting time per month and the inequality that goes with that. And I look here at this inequality and I can divide everything by 10 to make it look slightly simpler before I move on. So this is the same as 2F plus 3S is less than or equal to 600. And this one down here is the same as 2f plus 1s is less than or equal to 400. So, these are my constraints. This and this. All I need to do now is find out how to make the decision on what the best number of lamps is. And I would imagine that would be based on profit. We want to increase the profit, so we actually want to maximize the function which is profit. So let me add one more row to my table about the total profit. So we have F funky lamps and we have $15 from each of those. And we have S snazzy lamps and we have $10 from each of those. And so these together would be my total profit, 15F plus 10S. So now I can write the whole thing as a linear program. I want to maximize that profit. Maximize the profit, so let's call it P, which was equal to 15F plus 10S subject to, and now I put in my conditions. My conditions are here and here. So 2F plus 3S is less than or equal to 600, and 2F plus S is less than or equal to 400, and S and F are certainly greater than or equal to 0. And now this is a purely mathematical problem, and I can solve it by drawing a diagram because I've only got two variables. So let me draw a diagram. So here's some axes, F and S, and I want S and F to be greater than or equal to 0. So I'll cross out the bits where they're negative. Don't want these bits here. And then I'll put in this one. If it was an equal sign here, that would be a line. 2F plus 3S is equal to 600. And the easiest way to draw a line is to draw its intercepts. So when F is 0, I get 3S is equal to 600. So S would be equal to 200. So 200 here. And when S is equal to 0, I get 2F is less than or equal to 600, so F is less than or equal to 300. 1, 2, 3. Just there. And my line looks like this. Now I want it to be less than or equal to 600. So that should be below the line. I'll just check. If I put in F equals 0 and S equals 0, I get 0 plus 0 is less than or equal to 600. So yes, that's correct. I want the bit below the line. So I'll cross out the bit above the line. And now let's do the other inequality by the same method. If F equals 0, that gives me S is less than or equal to 400. 400. And if S is equal to 0, that gives me 2F is less than or equal to 400. So F is less than or equal to 200, which is here. So if I join those up, that's my line. And I want less than or equal to 400, so I want below the line again, so I'll cross out the bit above the line. And my set is the bit that's left that's not coloured in. So let me cross out all my crossing out and leave just the bit that's coloured in. So this is what my set looks like. Now the theory of convex sets and linear inequalities tells me that the maximum, wherever it is, will be at one of these vertices. This one, this one, this one, or this one. So if I calculate the coordinates of all of those vertices and put them into the formula for the profit here, whichever one gives me the highest is the place where the maximum happens, and the value of F and S there are the numbers of each different type of lamp that I need to produce the maximum profit, and that will answer my question. So all I need to do now is actually calculate the vertices. Well, these ones here are easy to calculate. This one, and this one, because they're on the axes, I can just write down their coordinates. It's this one here that's the tricky one, so let me do that formally. Find vertices 2f plus 3s is equal to 600 is the equation of one of those lines, and 2f plus s is equal to 400 is the equation of the other line. So if I do equation 1, take equation 2, that will give me no f, and 2s is equal to 200, so s is equal to 100. And if I substitute back into equation 2, I'll get 2f plus 100 is equal to 400. So 2f is equal to 300, so f is equal to 150. So those, s equals 100, f equals 150, are the coordinates of this vertex here. So all I need to do now is find out what the profit is at all of those 4 vertices, and I'll start a new page to do that. Let me draw a table. Vertex and P. So I just need to write down the coordinates of the vertices now. Let me go back to my picture. This vertex here is 0, 0. This vertex here is 0, 200. This vertex here is 200, 0. And finally, this vertex here is 150, 100. So now I just need to calculate the profit, and the profit is 15f plus 10s. So 15 times 0 plus 10 times 0 is 0. 15 times 0 plus 10 times 200 is 2000. 15 times 200 plus 10 times 0 is 3000, and 15 times 150 plus 10 times 100 is 3250. So the maximum profit is 3250. And it happens when f is 150 and s is 100. So max profit of $3,250 occurs when F equals 150 and S equals 100. So 150 funky lamps and 100 snazzy lamps should be made each month. The end.